Hi everyone, my name is George, and in this video I will share with you my first results using a 122mm APO refractor from Svbony. The model of this telescope is SV550. So I got this one at the beginning of August, and since then I've collected a little more than 20 hours of exposure time on different targets. And let's take a look at the images that I got. Let me know what you think about these images in the comment section down below. I have also uploaded all these pictures to my page on Astrobeam, so if you want to take a closer look and check these images out at the original size, you can do that following the link that is in the description to the video. And right now let's actually take a closer look at the telescope, at the whole setup, and I will tell you a little more about it. The star of this video is of course a 122mm APO refractor SV550. So it is a triplet refractor with FPL51 ED glass. Although it is not a higher quality one, FPL53 glass, I'm personally happy with the images I've gotten with this telescope so far. So on the bottom we also have 0.x focal reducer and flattener that brings down the focal length of this telescope to 683mm, and f ratio with the focal reducer is f5.6. I know some people online mentioned that it also would be nice to have a just flattener for this telescope. I personally wouldn't mind to capture deep sky objects at original f7 focal ratio. We can capture some bright deep sky objects and keep the original focal length of this telescope. Let me know what you think in the comment section down below. Should Svbony develop a flattener for this telescope, or 0.x focal reducer and flattener will be just fine? Okay, also some people online had questions about connecting the ZWO focuser to the focuser of the telescope, and this is how it looks on my setup. So basically there are two screws that I use to connect the focuser mount to the focuser of the telescope. And also thing you want to pay attention to is this one. So this screw, this hole actually has two Allen screws inside it. So the first one plays a role, as I understand it, as like a protection, as a cover for the hole. Once you unscrew the first Allen screw, there will be a second one that used to keep this focusing mechanism on the other side over here. So yep, this is how it looks like. I hope it helps others who want to connect their electronic focusers to the SV550 telescope. So far I've been capturing deep sky objects using my ZWO 2600 MC Pro camera. This is a one-shot color dedicated astrophotography camera that has the APS-C size sensor, and it matches the imaging circle of this telescope pretty well. Yes, I do have a little bit of vignetting on my images, but it is easily corrected with flats. And by the way, I recently purchased this flat panel that also plays the role of the cover for the telescope. So besides the opportunity of taking flats anytime I want, I also got an opportunity to cover the lens of the telescope anytime. So for example, once the imaging session is over and the telescope is parked, this flat panel switches to a closing position and the lens is protected from the potential outside influence, such as the bird poop that, for example, I have on the top of my telegizmos cover. In my first video about this telescope, I had a 30mm mini guide scope placed on the top, and my first images I got with the help of the mini guide scope. But later on I decided to switch to a 50mm guide scope from Orion because I can see a little more stars and the picture just a little brighter, so that the guiding will perform a little better than with the 30mm guide scope. All the time I control my telescope remotely through a mini PC that I have here on the top. This is the mini PC from the company called Mealy, and I've used this mini PC in particular since last year, no issues whatsoever. I connect to this mini PC through the TMViewer app or through the app called Microsoft Remote Desktop if I connect to the same Wi-Fi network as this mini PC is connected to. So the opportunity to control this telescope remotely allows me to do most of my imaging sessions from the inside. Or let's say if I'm not at home, I can connect to this telescope from any location in the world and run my imaging sessions. Also, what I want to cover about this telescope is the built-in rotator. So just a reminder, by unscrewing this knob, you can adjust the angle of the camera and change the orientation and field of view in the way that you want. What I notice is that sometimes when I change the angle and rotate this part of the telescope counterclockwise, I also unscrew this part, the black part of the telescope, which is not okay. I'm not sure if it's supposed to be like that. So what I did is tighten this part and made sure that it's solid. And when I adjust the angle of this part, I always keep an eye that I do not unscrew this part by accident, and that's what you might want to keep an eye on as well, guys. So usually I keep my telescope outside like this 24/7. During the daytime, the telescope is covered by the Telegizmos 365 cover that helps protect all the gear inside from the outside influence, such as the sunlight, rain, or for example the cross sprinkles that I have here earlier in the morning or before the sunset. Everything stands on a DIY made telescope cart that I built up earlier this year. So basically what I do if I have extremely bad weather conditions, I just roll out this cart to garage where it's safer for the telescope and all the equipment. And once I have clear skies again or like nice weather conditions, I just roll out the telescope from the garage to outside, point the telescope cart towards the Polaris star. When there is the nighttime, I would polar align the mount, and then I'm ready to go for imaging session. Okay, and there is also one thing that I wanted to show you. So this is the camera that I use to keep an eye on my telescope. It can rotate to different positions, so I can turn it left and right and keep an eye on the telescope. And the camera is so sensitive that I can even see the stars and check out different areas of the sky for the presence of clouds. So for example, if I see that something is wrong with my images, like they became dim or something, I just point this camera towards the area of the sky where my telescope is pointed to, and yep, in most cases there can be either the haze or clouds, and then I look for a better quality area of the sky and change the position of the telescope. Let's cover how the imaging sessions look like. I'm actually recording this clip 4 nights after I filmed clips from the outside, and since then I've been capturing deep sky objects every night. Tonight is Monday, September 4th, the Labor Day in the United States, and I got another clear night. So right now my telescope is pointed towards the North American nebula, and I photographed this region using all of my telescopes, I think. I really like this area of the night sky for test purposes because in one field of view there are different types of objects, like emission nebula, dark clouds of dust and gas. There are stars around the field of view with a different brightness. So far I've collected almost 10 hours worth of exposure time on this target. Right now we have nights with bright moon in the sky. Because of that I used a dual narrowband filter SV220 from Svbony that only passes hydrogen alpha and oxygen 3 emission lines, and on the screen you can see how the single exposure look like. However, the North American nebula is not the main project that I've been working on. Last year I collected 24 hours worth of exposure time on the Andromeda galaxy with my Skywatcher 880 telescope, and this year I have a different galaxy to work on, and I want to collect at least twice more the amount of data that I did on the Andromeda galaxy. This time I work on the Messier 33 galaxy, also known as the Triangulum galaxy. Now, a lot of people photograph this galaxy every year, and I think in a few weeks we're going to see more pictures of this galaxy on our social media feeds. However, not a lot of people try to reveal nebulae that lie within this galaxy. If you take a picture of the Triangulum galaxy in the broadband, you will see of course the galaxy itself, and yep, you'll be able to reveal a couple of bright nebulae that lie within the galaxy. But there are many more objects that stay hidden from our eyes. And the idea of my project is to reveal this nebulae. Of course, it might not be a good idea to do this project with a one-shot color camera, because with a monochrome camera I'd be able to get a better result. However, that's the only camera I have at the moment with a big sensor, so I decided to go with ZW2600 MC Pro. And same idea with the North American nebula, since we have a bright moon in the sky. During the last 4 nights I've been collecting light with the dual narrowband filter, and I got almost 20 hours worth of exposure time with that. Okay, so right now The telescope is finishing sequence on the North American nebula. As you see, I planned 30 frames to capture for tonight. Each frame has 5-minute exposure, and basically, like in less than 4 minutes, my telescope should salute to the Messier 33 galaxy, and then we're going to look at the single exposure on that target. So for M33, I've planned 72 frames to be taken. So as you can see, NGC 7000 sequence was finished, and Nina software just switched to M33 galaxy. Also, you can see on the screen that the telescope is pointing towards the Triangulum galaxy. Alright, so the telescope just centered the Triangulum galaxy in the same field of view, and this is also the key to successful imaging, is to point the telescope to exactly the same area of the night sky, so that you'll be able to collect more data on the same part of the sky. Okay, now my telescope is going to check the focus of the image, and after that the sequence for the Triangulum galaxy should begin. So I started this project earlier in August, when I captured 15 hours worth of exposure time on the Triangulum galaxy in the broadband. And what I wanted to do is to collect at least 20 hours worth of exposure time in the broadband, and maybe to collect like something around 30 hours captured with a dual narrowband filter, so that I will have 50 hours worth of the total exposure time, and I hope I should get a decent image on the Triangulum galaxy. So if you're interested in the final result, please consider subscribing to my channel to stay in touch. To sum up, at the beginning I showed you some examples of the images that I got with a one-shot color camera and SV550 122mm APO refractor from Svbony. I also showed you how the setup looks on the field and covered some parts of this setup. I shared the imaging workflow, which basically looks like uncovering telescope before the imaging session, setting up the imaging session in the Nina software, and I didn't cover this part in really details, but the idea is that each clear night that I have, I capture the same area of the night sky. Every time I collect as much light as I can to reveal more details of the image. And at the end of my imaging session in the morning, I cover the telescope back with the telegizmos covered. Yep, this is how the process looked like. If you found this video interesting or helpful, please consider subscribing to my channel, hit this video the like button, and consider leaving a comment in the comment section down below. This is always appreciated, guys. As the final reveal image for this video, I'm going to share with you a picture of the North American nebula that I didn't get yet, but I'm going to get. I don't know how much exposure time I will have by the end of this video, but I hope you're going to enjoy the picture of the North American nebula, and in a few, I don't want to say days, in a few weeks maybe, I will post the image of the Triangulum galaxy. So also consider subscribing to my channel for that image as well. I really hope to see you in the future videos, guys, and until next time.